If you want to graph this function, at least just a little piece of it, because we're talking about 1/3. So if this is 1/3 will be somewhere here. So at least a little piece here, I would like to graph this function. It's a sine, even if it's the amplitude is 2, it doesn't really matter. It's just going to go to 2, but still it's a sine function. So it will look something like this, right? So at least I'm graphing this piece. Okay, I am not interested to put this function to this point in. No, not at all. So on this function, which is y equals 2 sine pi x over 2, I'm going to choose a point anywhere. I don't know what this point represents. I don't care, but it's a point on the graph. So it must have an x and a y. So this is the x value, and this must be the y value. So this point is definitely point P of x, comma, y, which is 2 sine pi x over 2. And the distance between the particle and the origin is definitely this line. That's the distance between the origin and the particle. So OP is the distance. So first of all, I have to identify what the problem is asking me to determine. So I'm going to give this a name. Do not give a name as a D because that stands for derivative. So I'm just going to call it W. So obviously this is a right triangle with a point on the graph. I don't know where it is again, and I don't care. And I will not even look at that because that is given that. So that has to wait. From this right triangle, I immediately write that x squared plus the y, which is the function squared, 2 sine pi x over 2, everything squared, must equal w squared. So I found the relationship between x and y and w. But I know y is the function value for x. So one more time, what is the question here? Well, the question is to find the rate of change of the distance between the particle and the origin when x equals, now I can look, 1/3 and y equals 1. Now, also I have to identify what this is here. What does it mean? It says when the x coordinate, dx over dt, changes with the square root of 10 centimeters per second. So this is at the same instant when x is 1/3, when y is 1, we don't need to do this, but I'm just emphasizing, and when dx over dt equals the square root of 10. So obviously at this point, I'm going to differentiate implicitly and get dw over dt. X is a function of time. W is a function of time as the particle is moving along this curve. So I differentiate the left-hand side. I get 2x. I differentiate this. So I bring down 2 sine pi x over 2 times the inner function prime. So I could have just said 4. So this is basically 4 sine squared pi x over 2. So maybe that would be better to do. Okay, so that would be 8 because now when I differentiate the inner, I have to make sure that I put this 2 again. Times cosine pi x over 2 times the inner function prime, which is pi over 2. Let's do this piece one more time. So I bring 2 in front. I subtract 1 from the power, and now I have to differentiate the inner function. So when I differentiate the inner function, I have 2. I have sine prime, which is cosine. I have pi x over 2 prime, which is pi over 2. And finally, equals 2 w dw over dt. So let's stop and see if you have any questions on this so far. Anyone has any questions on this problem so far? Anything?
Yeah, where does the fourth 2 in the upper line come from again?
This one?
At the bottom, after 2 times 2 sine pi over x divided by 2, the 2 right after the closed parentheses.
This one?
Yeah. Yeah.
Okay. So let's, but you understand the 2 squared and the sine squared, correct?
Okay.
Yes?
Yes.
Okay, when I differentiate this, let's see what happens. I bring 2 in front, I get 8. I have sine pi x over 2 to 2 minus 1 times the inner function prime, which is cosine pi x over 2, times the further inner function prime, which is pi over 2. Is this okay?
Yeah.
So then I have 8 sine cosine pi over 2. 8 sine cosine pi over 2. Now,
okay.
Now let me explain it also without doing this. So let me explain it one more time. So I have a function to the second power. So then I have 2 times the function, and here I have to have the function prime, the inside function prime. So 2 times the function to 2 minus 1 times this function prime. So when I differentiate this, I have 2, has to stay. I have cosine pi x over 2 times the inner function prime, which is pi over 2. 2, because I'm differentiating this. 2, sine prime is cosine, the inner function is pi over 2. Or you think in these terms, that's why I said right here, maybe that's easier. So I square first, 2 squared is 4, and sine squared. So 4 stays, but I have to bring the 2 in front, so I get 8. 2 minus 1 is sine. Sine prime is cosine. Inner function pi over 2. Inner function prime pi over 2. So 2 times 2 times 2, sine, cosine, pi over 2. Is that better?
Yeah, it makes sense. Thank you.
Thank you. Okay, very good. So now what I'm going to do is, since I have one term, the second term, and the third term, and I see all of them have 2 in front, I'm going to do this, simplifying. Not that this one goes with this. So this first term loses a 2, this term loses a 2, this term loses a 2. It loses one more because of the denominator here. Okay, so now we write again, x plus. So 2 with pi, 2 and pi, sine cosine. And I just realized dx over dt. Okay, one more time. I have to start from scratch now because I made an error here. So 2, x, as I mentioned, it's a function of time. X is a function of time. W is a function of time. Correction, sorry. So 2x dx over dt, careful. And the whole thing times the inner function pi over 2 dx over dt, and this is okay. So x dx over dt, okay, plus 2 pi sine cosine dx over dt, finally equals w dw over dt. If you need me to write it again, I will write it again on the next page, just to make sure that everything is clear. So I'm going to write it again, just to make sure there is no discrepancy here. I was just saying 3 times that that's a function, and I went ahead. Okay, so this is the equation. And now we differentiate implicitly, where x and w are functions of time. Just to make super sure. So 2x dx over dt plus 8 sine pi x over 2 cosine pi x over 2 pi over 2 times x prime, which is dx over dt, equals 2w dw over dt. Okay. So now this will go away, this will go away, and this will change into 4. And I'll simplify it again later. And I'm solving for dw over dt. This is our interest. This is our scope here, divided by w. So all that. So x dx over dt, and now 4 divided by 2 is 2, plus 2 pi sine pi x over 2 cosine pi x over 2 and dx over dt. So now it's done, because I need to just plug in x equals 1. And dx over dt equals the square root of 10. This, of course, has to come from here. I have to put the square root on all this. So I have this will be the square root of x squared plus 4 sine squared pi x over 2. So now let's see what we get. X is 1, that's nice. Dx over dt is the square root of 10 plus 2 pi. When x is 1, sine pi over 2 is 1, but cosine pi over 2 is 0. So all this is 0. Nice. Over the square root of 1 squared plus sine again of pi over 2 is 1, squared is still 1, so 1 plus 4. So then the final answer is the square root of 10 over the square root of 5, which will be the square root of 2. Measurement unit. Where is my measurement unit? Centimeters per second. Because the square root of 10 is the square root of 2 times the square root of 5 over the square root of 5, so I simplified. Any questions on this problem? Any step of the way? Anything? Okay, so that was 26. Now let's look at 32. Anyone, any questions in between? So again, it's very easy to forget. So I should have just written this from the very beginning, although I did say it, but then I got carried away. Okay, so page 3. And we said again, yes, it was 32. Let's take a look. I'm going to share my screen.
Sorry, could you put that back for just a second?
Absolutely, yes. Any questions? You may see something I don't. It's very possible. So that was the square root of 10. Yeah, but that's 0. Pi over 2 is 0. Cosine pi over 2. And then we have 1 plus 4, and this is 1. So that's the square root of 5. So it's the square root of 2. You can approximate at 1.41 if that's what you want. But don't ever forget the measurement unit, please. Is this better?
Yes, I'm good. Thank you.
Thank you. Perfect. So now we're looking at 32. Let's take a look. So 32. Where is 32? Okay. Okay, let's take a look at that one. So kite 100 feet above the ground. So good. Moves horizontally at a speed of 8 feet per second. So 8 feet per second must be something, and we'll see what it is in a moment. At what rate is the angle between the string and the horizontal? theta, decreasing. So let's see what we are asked to find when 200 feet of string has been let out. Okay, very good. Oh, I don't want to write it there. I just want to write X for now. But we're going to write it in a minute. So one more time, a kite 100 feet above the ground. This is fixed. Moves horizontally at a speed of 8 feet per second. At what rate is the angle between the string and the horizontal decreasing when 200 feet of string has been let out? Perfect. So here's my picture. So somebody is here on the ground, or it's somehow fixed. We don't have the height of the person holding this, so we assume that it's just on the ground. So he's flying this way.